Leading climate scientist Miles Allen says the traditional way of accounting for methane emissions from cows overstates the impact of a steady herd by a factor of 4, which he says is a problem. Allen goes on to say if we are going to set these very ambitious goals to stop global warming, then we need to have accounting tools that are fit for purpose. Allen says the errors distort cows' contributions, both good and bad, and in doing so gives CO2 producers a free pass on their total GHG contribution. Allen is a heavyweight in climate circles. The BBC described him as the physicist behind net zero, based on his work with the IPCC in 2001 when quantifying the size of human influence on observed and projected changes in global temperatures. In 2005, he proposed global carbon budgets, and in 2010, he received the Appleton Medal and Prize from the Institute of Physics for his work in climate sciences. Over the past few years, he has been the coordinating lead author for the 2018 IPCC Special Report on 1.5 degrees, and he has long been a proponent of fossil fuel producers being made to take responsibility for cleaning up after the products they sell, rather than shifting that onus on powerless consumers. All of this leads to cows and why he cares that the math is right. According to Allen, cows get lumped into the CO2 equivalent measurements, which the Oxford professor says is wrong. And that, says Allen, lets carbon producers off the hook because they can and do point to incorrect yet widely accepted accounting of cows' contribution to GHG production. In essence, they're blaming the cows rather than taking full responsibility. We invited Miles Allen to join us for a conversation that matters about why a steady herd size of cows is not the problem, and a slow decrease in herd size may in fact be part of the solution.
Conversations That Matter is a partner program of the Center for Dialogue at Simon Fraser University. The production of this program is made possible thanks to the following and viewers like you. Please become a patron at conversationsthatmatter.tv.
Professor Miles Allen, thank you for joining me on Conversations That Matter.
Well, thank you for inviting me.
Well, I'm fascinated in the work that you're doing for much of the course of your career, and as you continue to be focused on the production of greenhouse gases, largely anthropogenic greenhouse gases, and the contribution that they make to the atmosphere. But one of the elements in all of that is we take a look at the role of agriculture, and within that, what is the role of cows? And I'm trying to get a sense of, what exactly is that methane or CH4 contribution from cows to greenhouse gases? Are they producing new gases, or are they part of a carbon flow?
Well, it's very important to start off by saying that actually cattle do have a huge impact on our climate. The growth of ruminant agriculture over the past century and continued growth of ruminant agriculture around the world has actually had a huge warming impact on our climate. So methane emissions in total, that's not all from agriculture, a lot of it from energy as well, have contributed, almost a third to a half of the warming caused by CO2 so far. But what's interesting is the way in which methane affects climate is very different to CO2. And that's what we're starting to, it's been well known for a long time that they behave very differently, because methane is a short-lived gas. It only persists in the atmosphere for around a decade or so, whereas carbon dioxide has an effectively permanent impact on climate. You put a ton of carbon dioxide into the atmosphere, it ratchets up global temperatures, and then they stay there. Whereas if you put a ton of methane into the atmosphere, it pushes up global temperatures by a lot more than a ton of carbon dioxide in the short term, but then that slowly dissipates away. And that's the important difference between these two gases.
Okay, so when I look at the release of methane from, well, either pulling natural gas out of the earth on its own or as a byproduct of oil exploration, I go, yes, we're introducing what had been a sequestered resource back into the atmosphere, and it is a dense concentration. When we're looking at cows, however, I'm trying to understand. Okay, they are consuming when they eat is sequestered carbon in the plant material that they eat, and within their bodies, they're converting it back into methane. Are they actually contributing new greenhouse gases, or is that a part of flow?
Well, this is the big difference between methane and CO2 is that yes, the cows are contributing to, climate, the way our climate is. But the important difference between methane emissions and CO2 emissions is that methane emissions, it's the changes in emissions that really count. So, a good analogy that may work for some of your listeners is this. You remember, like 10 years ago, these really dangerous financial products where you could bet on the movement of a stock. And so you could manage to lose money on a stock even if you still held it because you bet on how the price had shifted. Or you could make more money even than the value of your investment by betting on the movements. So these kind of weird financial instruments played a big role in the 2008 financial crisis. Methane is a bit like one of these financial instruments in that it's got a huge leverage on its impact on climate. In that if methane emissions go up a little bit, they have a big warming impact. But interestingly, if they're stable, they have much smaller warming impact. And even more interestingly, if methane emissions decline, they can actually have no warming impact at all, or even a negative impact on global temperatures, drawing down global temperatures with them if they decline fast enough. That's completely different to carbon dioxide. Carbon dioxide causes global warming no matter whether carbon dioxide emissions are going up or stable or going down. Every ton of carbon dioxide you dump in the atmosphere ratchets up global temperature. Whereas methane, it all depends whether your emissions are going up, stable, or going down. And we've been working very hard over the past few years on how we can capture that difference in behavior in how we compare these gases in climate policy.
It is an important distinction. If the cattle population globally were remaining stable, and I did a little bit of research before
It,
our,
it's, it's not, that's important. But yes,
yeah,
but if it were,
yeah. If it were remaining stable, or if it were to decrease, you say it could have a positive impact on global cooling. Is that right?
well, yes, a declining cattle herd is drawing down global temperatures because as the cattle herd declines, the methane emissions associated with it fall. And because methane is a short-lived gas, concentrations in the atmosphere fall with it. That's completely different from carbon dioxide. Carbon dioxide, declining emissions just mean you're warming the planet a bit slower. So if you decline emissions of carbon dioxide, the warming they cause goes up and it slows down, but you actually have to pull carbon dioxide emissions all the way down to zero to actually stop carbon dioxide from causing global warming. But you can stop methane emissions from causing global warming simply by reducing them at at a reasonable rate, 3% per decade. But that's means 10% over 30 years.
Okay, so you were quick to jump in when I started talking about global cattle population to say, no, it's not going down. When I take a look here in North America, there's a suggestion that the total cattle population is down somewhere around 10 to 15 million cattle in North America over the last 30 or 40 years. But globally, that's not being reflected, I guess, particularly in Brazil and India.
Yeah, we're seeing a shift in the cattle population, and the overall trend is towards ever more livestock, and that is causing a lot of global warming. But the problem we have is that the way we measure that warming doesn't capture the enormous importance of these changes in uh, in ruminant numbers, in methane emission rates. And that's something that we've been saying ought to be addressed, because we need to actually grasp the opportunity provided by our agricultural system to actually meet our climate goals. We need to get agriculture into climate policy. We can't just ignore it and leave it alone, because it is an important lever we need to pull in addressing climate change. But my argument would be, and I think many farmers would probably agree with me, that we should make sure the lever is well calibrated, that the lever is accurate, if you like, as we pull it. And the big difference between thinking about the traditional carbon footprinting that people tend to talk about, when they just convert methane emissions into carbon dioxide emissions just by multiplying by a number, that doesn't capture the importance of whether methane emissions are going up or stable or going down. And we've been trying to develop ways of capturing that behavior, because if you've got a herd of cattle that is gently declining, as I say, 10% or so over 30 years, then that herd as a unit is not pushing up global temperatures. And yet, in the conventional accounting system, it would be treated as if it were a small power station, still driving up global temperatures. So that's something that I think will need to be addressed if we're to bring farmers along as we incorporate agriculture into climate policy. Because it's really important to stress there's a massive opportunity here, because if we can reduce our methane emissions faster than 10% over 30 years, we can actually compensate for some of the warming that's being caused by other things. And, one argument I think we should be having is, if farmers are compensating for the warming caused by car drivers, for example, should the farmers be rewarded for that? I mean, there would be a strong case for that. But at the moment, the way in which we treat greenhouse gases would exclude that possibility.
Do you worry that with the way that we're treating, the agricultural biogas contribution to greenhouse gases, skews the ability of decision makers to make the most appropriate and informed decisions about how we will address climate or our CO2 emissions, how we're going to reach the targets that we're aiming to achieve by 2050?
Yes, we've set ourselves a goal of stopping global warming. And so, in my view, it should be obvious, to quote a former US president, it's the warming, stupid. So it should be obvious that we should compare activities in terms of their impact on global temperature. So if an activity is causing global warming, we should discourage it. We should incentivize activities that reduce global temperatures, and we should discourage activities that increase global temperatures. That seems the logical thing to do. It so happens, because we are sort of saddled with this 30-year-old accounting system, which treats all these gases as some kind of carbon dioxide equivalent, it's not fit for purpose. It doesn't actually measure impact of activities on global temperatures. And it's easy to fix. I mean, if you don't mind me just giving the numbers, I think if you've got farmers listening, they probably want to know the numbers. If you want to know how much carbon dioxide your methane emissions are actually worth in terms of their actual impact on global temperatures, then you need to multiply today's methane emissions by 112, so it's a big number, but then you need to subtract methane emissions from 20 years ago, multiplied by 105. So another big number, but the point is, because these are two big numbers, if your emissions are declining slowly, then they actually net out to zero. So that's where you get the effect, the enormous impact of these changing methane emission rates. In contrast, the old way of treating methane emissions is just to multiply your methane emissions by 28, so one number, and not take into account whether they're going up or going down at all. So in consequence, the traditional way of accounting for methane emissions, it overstates the impact of a steady herd of cattle by around a factor of 4. So it's not a small effect, it's a factor of 4 error if you've got a constant herd. But it also understates the impact of any new increase or decrease in methane emission rates, also by around a factor of 4 for around 20 years after the change occurs. So, these are big errors.
Do we also have to be careful that we don't take a one-size-fits-all approach or look at this? Because we may see things that are happening in northern hemispheric countries where we're seeing a decline in cattle and dairy population for a whole host of reasons, from consumer choices through to better agricultural practices and so on. But in southern hemisphere countries where economies are still emerging, we're seeing an increase in cattle populations. How do we, start to find a balance so that there can be this net benefit from agriculture, and in particular from cattle and dairy cows?
Well, the really important thing is, I'm a physicist, so I can tell people how emissions affect climate. What we actually do about cattle numbers and the redistribution of cattle around the world and so on is, of course, dependent on lots of other things. Yeah. I mean, big ethical decisions about how we want to manage our land, or how we prioritize human activities against natural ecosystems and so on, and also how we weigh up the interests of rich and poor countries and so on. So there's a thousand different issues involved in making these decisions. But one thing I do feel very strongly about is we shouldn't use, greenhouse gas accounting rules to achieve a different outcome. Even if we want that outcome, we should say so. We should say we want this outcome because we want to rebalance, meat consumption between the North and South. That would be a very good thing to do. Mm-hmm. In the global North, we eat too much meat. We eat more than's good for us. And in the global South, they probably could do with eating more meat, many of them. So, that great rebalancing should be happening. But to use, greenhouse gas accounting rules that are just wrong to achieve it is just sort of muddying the waters. It's not really, it's not a good way of doing things. Two wrongs don't make a right here.
Your point is that we have to make sure that we're moving forward with the right information so that we can make the appropriate decisions.
The science of how methane affects global temperatures is very well established. And although this new way of thinking about methane that we've been working on, it does have its critics. The critics are on other implications of it, not the science itself. Everyone says, yeah, the science is fine, but people are worried about the implications, and they're particularly worried about the fact that farmers might, grab onto this to think, great, global warming is not something I need to think about. Well, actually, it's almost the opposite message. If you own one of these leveraged financial products that I mentioned, you should be really worried about what that stock price is doing, whether it's going up or down, because you've got this heavy leverage in your portfolio. And methane is just like that. So we should be very conscious of what methane emissions are doing, whether they're going up or going down, because they have this enormous impact on global climate. But we need to characterize it correctly. You need to know what the value of your portfolio really is.
I have looked at farmers' fields, and I've been out doing quite a number of conversations about agriculture and its role, not only in our lives because it's so substantial, but I look at all that sequestered carbon, and I think that if we can demonstrate that if farmers employ agricultural methods that do exactly as you say, help to bring down the total number of greenhouse gases, do we not also then put them in a position where they can become, one of the vehicles that they can sell our carbon credits just for being farmers? Or is that a misplaced idea that I might have?
No. We will need the land to take up carbon so far, up until now, the land and the way we've approached agriculture has been a major source of carbon. We've actually released a lot of carbon from our soils. So it's really important that we start to put that carbon back, and good soil management can do that. We reward farmers for taking carbon back out of the atmosphere. And that's an important service that farming can provide.
So when you take a look at some of the advances in agriculture, because somebody once described it to me, it is the oldest profession in the world with the greatest amount of innovation and opportunity for change. Are you encouraged by what you see, especially when there is this focus on greenhouse gas contributions?
I think agriculture can make a very substantial contribution. Actually, I think an underappreciated contribution to achieving our climate goals. But it's also important to keep that contribution in perspective. I mean, the even if we, just to sort of give you some numbers, even if we managed uh, very ambitiously to halve our methane emissions over the next 30 years or so, that's from both agriculture and energy. That might shave a tenth of a degree or so off global temperatures by 2050. Now, right now, carbon dioxide from fossil fuels is driving up global temperatures by 2/10 of a degree per decade. And that's overwhelmingly from fossil fuel use. So you've got we've got to stop fossil fuels from causing global warming. If we do that, agriculture can really help us in keeping the total warming we end up at lower than it would otherwise be. But at the end of the day, if we don't stop fossil fuels from causing global warming, then everything else is a bit moot. So we do need to be careful to keep these things in perspective. Agriculture can be helpful, but at the same time, if a this is entirely hypothetical. It's not happened yet. But if a petrol company, if an oil company were to come to me and say, you can buy our petrol because we're paying some farmers to get rid of the carbon, I'd be pretty skeptical about that, because at the end of the day, the two numbers are so different. So we need to be careful to yes, agriculture can be a huge help, but it can only be a help if we get our fossil fuel emissions under control and ultimately get those emissions down to zero.
Well, I tend to be a optimist and believe in our ability to address the challenges of life. It's what has got us to this point, and I'm hopeful that collectively we can work towards the kinds of solutions that will ensure that we can remain healthy and living in a healthy environment. Thank you very much for taking the time to do this interview with me.
I completely agree with you. I think there's lots of solutions out there, and we just need to get everybody working together and avoid some of the antagonism that has plagued the climate problem over the past couple of decades.
Yes, thank you.